Today we're going to be talking about chemical reactions. So PS5B is chemical reactions, and students are going to investigate the relationship between reactants and products. We're also going to investigate endothermic and exothermic reactions. Our essential question, which you need to write at the top of the Cornell notes, will be how is energy involved in chemical reactions? This is our big idea. So how is energy involved in chemical reactions? Well, there's two ways. The first way is to break some or all the bonds between atoms in a reactants so atoms can form new bonds. Or the second is when an atom or product form new bonds to make new products. We're going to talk more about reactants and products as we go through. The first couple equations I want to show you here are two different equations. One is an exothermic reaction, the other is an endothermic reaction. Take a moment and try to think which one do you think is endothermic and which one do you think is exothermic. So let's take a look here and try to figure out each one. So we classify chemical reactions based on how the energy of the reactants compares to the energy of the products. So let's talk about what reactants and products are. So if you are on the left side of the equation, those are reactants. The right side are the products. So for this first equation, we have fossil fuels, which are kind of like coal, oil, natural gas, plus your oxygen will make carbon dioxide, water, and energy. So these are your products over here. This one is an exothermic reaction because we have fossil fuels and our oxygen, and what we're making is carbon dioxide, water, and energy. This is what happens in your car or in when you're burning natural gas to heat your home or at a power plant. Okay? The bottom one, okay, is an endothermic reaction. So carbon dioxide plus water are your reactants plus energy, okay, will make your products, which are just glucose and oxygen. So endothermic needs energy. Energy goes into the reaction. This is a common one where we find in photosynthesis. So our next part of our notes are what are exothermic chemical reactions. So if you look here, exothermic, energy released, energy used. We're going to get more energy released here than we use. So a fire is a good example. Energy is being given off. So if forming new bonds release more energy than it takes to break the old bonds, the reaction is what we call exothermic. So energy is released and the temperature increases. Exothermic reactions. Okay, here's our equation for exothermic reactions. A good example. But once you start the exothermic reaction, it tends to keep going until all the little molecules release more and more energy until they're all done. So here's an example of hydrogen being released. And we did this with our covalent bond lab with the electrolysis, water electrolysis, where we burn the hydrogen coming out. And this is an equation for making water. So we have our oxygen plus our hydrogen, and that makes water and energy. So a good example of the reaction of hydrogen with oxygen. So write down the equation and label the reactants and the products on your notes. Our next one is endothermic reaction. So here's a new section. An endothermic reaction is pretty simple. It's the opposite. It's forming new bonds in the products, releases less energy than it took to break the original bonds. The reaction is what we call endothermic. So what you need to know about this is energy goes into the reaction and the temperature decreases. I've included this picture here because it's photosynthesis, kind of like sunlight. It takes carbon dioxide and it takes the water and it makes our glucose and our oxygen that we need to breathe. So this is what we consider an endothermic reaction. So here's our example. Once again, our chemical equation, and an important endothermic reaction is photosynthesis. Plants need this energy from the sunlight to make glucose and oxygen from the carbon dioxide in the water. So once again, our reactants are on the left side, products are on the right side. Examples of endothermic reaction might be a cold pack. If you ever got hurt at a baseball game or some sporting event, they usually have those little ice packs, and inside you'll see a sealed pack of water and something called ammonium nitrate crystals. And when you break that sealed pack of water, it mixes with ammonium nitrate. Well, what this does is most of the reaction is used to actually absorb energy, and it becomes colder. The temperature decreases. So the reaction taking place inside an instant cold pack is what we call endothermic. Up here it says industry uses a lot of endothermic reactions because it requires more energy than what they produce. Okay. Another example of endothermic would be the equation here, same thing we talked about. Hey, when you squeeze that plastic bag in the water, it reacts with the ammonium nitrate crystals, and the reaction dissolves the ionic bonds in the ammonium nitrate. So energy is going in. That's why energy is on. That's why energy is on the left side, on the reactants. Okay. So real quick, let's review. Some chemical reactions are endothermic, which means they take in or absorb energy. Some chemical reactions are exothermic, which means they give out or produce energy. Heat, light, sound. That would be exothermic. So how can you tell a difference? Right. All right. Energy will be the energy will be on the reactant side of the chemical equation if it's endothermic. Causes temperature around it to cool. Examples: photosynthesis and crackable ice packs. An exothermic reaction, energy will be on the product side of the chemical equation, and it causes the temperature around it to rise or feel warm or hot. Think of cellular respiration. We take in the oxygen. We have our glucose, which is our food, right? And that reacts to produce carbon dioxide and water. We give off energy, our ATP. Glow sticks is a good example. Hot hands, all good examples. What I want to do here real quick is to kind of show you a quick video. Now you're not going to hear any sound, but I'm going to show you a quick video on YouTube in which you can see a chemical, an endothermic and an exothermic chemical reaction. So here he goes, and he's pouring some vinegar in. And he's going to mix it in the beaker. And he's going to take some thermometer and measure the temperature. And you'll see the temperature is going to be steady at the same temperature because nothing's really mixed in there without just the vinegar. When he adds the baking soda, we're going to fast forward a little bit. When he adds the baking soda, measures it out. Okay, he'll pour it in there, and you'll see the bubbles, which is an indication of a chemical change or reaction. And the actual temperature is going down. That's an endothermic reaction, so you can actually see that happening. Okay. We're going to fast forward over here to the vinegar again, and he puts something called steel wool in there. He's soaking it up. And the vinegar, which is an acid, will react to the steel wool. Okay. And after he makes it all soaked with the vinegar, and we're going to skip ahead, and you'll see the temperature is actually going up. It's actually increasing. It went up from 23 to 24 to 25. It keeps on increasing. That's an exothermic reaction. So there's a quick example. All right, promised I'd keep the videos under 12 minutes. So thank you for watching. And next class, we're going to be doing an experiment with exo and endothermic reactions. So be prepared.